Hello everyone. Here's a short video on an introduction to matrices and matrix operations. We will be using this background information tomorrow in class when we start talking about how we can use a matrix to solve a system of equations. It says here on this page that a matrix can be used to organize information. An example that you might see with a matrix would be a table of values or a spreadsheet that you might see. In this matrix, it says that the matrix represents the number of sports drinks, fruit juices, and waters sold this week from the vending machines at the main entrance and the back entrance of the school. So what we're doing here is we're organizing our data in 3 rows. This would be the sports drinks, these would be the fruit juices, and then the bottom would be the water. And then going down the columns, we're talking about the main entrance would be this column, and then the next column over would be the back entrance of the school. So for example, the 98 that you see right there would be the number of bottles of water sold at the main entrance, so that would be 98. The 33 in the upper right hand corner, since it's in the top row, it would be the number of sports drinks, because sports drinks was listed first. Since it's in the second column, it would be the number of sports drinks sold at the back entrance of this school. So again, it's just a way to organize your information in a table. The table is set up with these little brackets to hold the numbers in place. And the important thing about a matrix is that you understand what the dimensions of a matrix are. The dimensions of the matrix give the numbers of rows and columns. So with this matrix, we have a 3 by 2 matrix because there are 3 rows, 1, 2, 3, by 2 columns, 1, 2. This is a 3 by 2 matrix. If you want to talk about a specific element in the matrix, an element is a specific number in any spot. You would refer to it by its row number and column number. So here they say A31 is 98. Not really 31, A31, meaning the item in row 3, column 1 is 98. Okay? So again, this is just an example of a 3 by 2 matrix. 3 by 2. On the next slide, we see that our good friend Neo here says that we see what a matrix is. Let's take a look at different operations that you can do with matrices. Sorry, I was in a bit of a matrix mood. Let's go here and talk about adding and subtracting matrices. This is the most straightforward operation, or 2 operations that you could have with matrices. To add 2 matrices together, matrices, by the way, is plural for matrix. You want to make sure, first of all, that your dimensions match. In this case, we're adding a 3 by 3 matrix with another 3 by 3 matrix. It's very important that the dimensions match when you're adding. For example, if we were trying to add a 3 by 3 matrix with a 3 by 2 matrix, we would run into a problem. Because what we do is we just add 5 plus 1, then 2 plus -1, then 1 plus, if this row wasn't here, there would be nothing to add this 1 to. So it's very important that the dimensions match when you want to add matrices. So our resultant, or our solution matrix here, is going to have 3 rows and 3 columns, just like the 2 that we were adding. So we're going to need spots over here for 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, very simple process to add matrices. You take the 5 plus 1, 6. Okay, in the next spot, we would have the 2 plus -1, 1. 1 plus -2, -1, and so on. At this time, I'd like you to pause the video and complete the matrix addition in your notes. All right, here we go. Here are the answers that I came up with. You have 6, 1, -1, 12, 13, and -2. 11, 8, and 4. So that would be the solution matrix to that addition problem, adding matrices. In the next slide, we're going to learn how to multiply matrices by a scalar. A scalar multiple is just a plain old number, a constant that we want to multiply by. In this case, we want to take our matrix, which is 5, 2, 1, 4, 8, negative 5, and so forth, times the scalar multiple 3. Basically, all we do here is we triple every entry that's in the matrix. So 3 times 5, 3 times 2, 3 times 1, 3 times 4, 3 times 8, and you go through and you multiply everything by that scalar multiple. Pause the video and complete your matrix. Okay, you should be back from pressing pause. Hopefully after multiplying the number 3 by every entry or element in the matrix, you got the same answers as me. Just to recap here real quick, the bottom right-hand corner, that 18, that would be the element in row 3, column 3. The 6 that you see in the top row, that would be in row 1, column 2. You want to really understand what a row versus a column is. It's very important to understand that going across, you have the rows. These are the rows going across. So row 1, row 2, row 3, and these are the columns as you look down the matrix, columns. And again, this would be a 3-row by 3-column matrix. Very important as we move into the next phase, which is matrix multiplication. Now, this is the first matrix operation where you're going to be a little bit confused at first. Let me just say that up front. The process is quite different from adding or doing scalar multiplication. With matrix multiplication, where you're actually taking one matrix times another, here's how it goes. You notice, first of all, that these matrices aren't balanced. This is a 2 by 2 matrix. And this one would have 2 rows and 3 columns. This is a 2 by 3. You might think that that's bad, but it's actually good. The one thing that we really need to happen when we're going to do matrix multiplication is the number of columns in the first matrix must match the number of rows in the second matrix. You could do a 2 by 2 times a 2 by 8. You could do an 8 by 2 times a 2 by 15. As long as the two numbers in the middle match, we are happy. Okay? We're happy if we have the two numbers in the middle matching, and here's why. When you multiply matrices, you're going to multiply this top row times this first column. And what I mean by that is, let me clarify this. Let's use my highlighter. You're going to take this green row times this green column, and here's how it works. You take the 0 times the 3, 0 times 3, and you add -1 times 0. 0 times 3 plus -1 times 0. Let me write that down up here. So you do the 0 times 3 plus -1 times 0. That would be 0 plus 0, which is 0. In row 1, column 1 of your answer matrix, or your product, you use the data from row 1 of the first matrix times the data from column 1 of the second matrix. Again, a little bit confusing. Now, let's just follow through with this. Let's try to get this entry right here. It's going to be the number in row 2, column 1. Let's think about that. To get the answer or the element in row 2, column 1, you're going to take row 2 times column 1. Okay? And you're going to do, just like we did the last time, you're going to do 2 times 3 plus 1 times 0. 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 6 plus 0, 6. Let's wipe the slate clean here. Let's wipe the slate clean and let's try the next entry. See if you get it. Bear with me. Stay with me here. We will get this together. Let's try to find the entry that will go right up here in the blue blank. The first thing you want to think about is this would be in row 1, column 2. Row 1, column 2. So we want to use row 1 with column 2. Row 1 with column 2. Again, you do the first times the first, so 0 times -2 plus -1 times -3. 0 times -2, 0 times -2 plus -1 times -3. That's 0 plus 3, which would be 3. Whoa, matrix multiplication is tricky. Row 1, column 2 came from row 1 and column 2. So now I'm going to move down and take that first box. I'm going to slide it down. Okay, that didn't work as well as I had hoped. Let's just cut that box out of there. And let's go ahead and do row 2, column 2. Row 2, column 2. That'll be right above the stars there. Row 2, column 2 will come from row 2 and column 2. Row 2 and column 2. We need to do 2 times -2. 2 times -2. 2 times the -2. 2 times -2 plus 1 times -3. 1 times -3. So 2 times -2 plus 1 times -3. I'm moving across the first row while I move down the second column. That's going to be -4 plus -3. This entry will be -7. See if you can come up with the last row. There's one more to go. We need to do row 1 times column 3 and row 2 times column 3 to fill out this last column. Press pause, see if you can do it. Okay, we're back, and let's see how you did for that last column. It is -5 and 13. Hopefully you got that as your last column to the matrix. And here's how I got that. I took the 2 from row 2, and I multiplied by the 4 from column 3. That makes 8. Then I took the 1 from row 2, and I multiplied by the 5 from column 3. 2 times 4 is 8. 1 times 5 is 5. 8 plus 5, 13. So row 2, column 3 produces the element in row 2, column 3. Okay, if you're not getting this, we will do a quick example tomorrow at the beginning of class just to make sure we're getting this matrix multiplication part. Wanted you to notice one thing as well. We had a 2 by 2 matrix times a 2 by 3 matrix. And what you should notice is what kind of matrix do we get as a result? You got it, 2 by 3. When the insides match, the 2 and the 2, you're allowed to multiply the matrices. Your result will take on the dimensions of the outermost numbers, the number of rows from matrix 1 and the number of columns from matrix 3. Matrix 2, sorry about that. So we had a 2 by 3. Okay, so those are the basics of matrix multiplication, multiplying a matrix by a scalar, and adding and subtracting matrices. It's basically just a way to group numbers. And Neo says here, stop. We're done. That's a 15-minute video on the basics. Now you know the basics on how they work and how they function. Tomorrow the future awaits, and what I mean by that is how we use these things to solve systems of equations. Coming soon to the actual classroom near you, room 545.